Hey guys, wanted to talk to y'all just a little bit today in our mini lecture about the three subatomic particles. So first of all, I'm just going to kind of go back over this lecture is meant to follow up behind the independent notes that you did and the PhET simulation. So first of all, it says name the three subatomic particles. We have the proton, the neutron, and the electron. Alright, the symbol for the proton is a little p with a positive, the neutron is an N with a 0, the electron is an E with a negative mark. So that is actually going to be how we determine their charges as well. The proton has a positive charge, the neutron has a neutral charge, and then the electron is negative. We look at the masses compared to each other. They're all real tiny. So instead of looking at times 10 to the negative 15th of a gram, what we do is we say that one proton has a mass of 1, one neutron has a mass of 1, and then the electrons are so tiny. They're only a fraction of this. So we say that the electron has a mass of 0. Now I know if it's matter, it can't have a mass of 0, but in comparison to the other ones, it's so insignificant it doesn't add anything, so we just say 0. The location, the protons and the neutrons are found in the nucleus, and the electron is found in the orbital. Now that can also be called the energy levels. So that's going to be where they're located. Now, those are the three subatomic particles. Now, if you look up here, I've written down the word atom, the word ion, and the word isotopes. So when you start looking at those three subatomic particles, protons, neutrons, and electrons, and you start varying their numbers, then each one of those, proton, neutron, and electron, has a specific effect on what atom you're talking about, the ion, or the isotope. So what I want to do is I want to look at just an atom, and I drew a lithium for you, and in chemistry, this is the way that we go through, and we'll move this over just a smidgen so you can see. This is the way that we go through and symbolize everything. So you see, this is Li, that's the symbol off of the periodic table for lithium. The 3 represents its atomic number. The 7 represents its atomic mass. So the atomic number is actually going to be the number of protons. So I'm going to put a P right here. And for this, I'm going to put 3. Well, when I said that the protons, neutrons, electrons affect atoms, isotopes, and ions, I was exactly correct. 3 represents the number of protons, and the number of protons in lithium is 3. So if I ever change that and I have 4, I no longer have lithium. If it changes to 4 protons, it's now considered beryllium. So the mass of it is going to help us to determine how many neutrons it has. We said that the protons had a mass of 1, the neutrons had a mass of 1, the electrons have a mass of 0. So I know that this mass number of 7 right here must be just the protons and the neutrons. So when I look at this, if I know I have 3 protons, then that means I would have to have 4 neutrons, 3 plus 4, to get the 7. And it's always set up when you do this. This is called a nucleic expression with the big number, the mass number, over the smaller number, the atomic number. So I can say this number subtracted by this number gives me the number of neutrons. Finally, we have the number of electrons. Whenever you're doing the number of electrons, if the atom does not have a charge, and in this one, if it had a charge, I would put the number right here. That'd be like a little +1, +2, or a -1, -2, just to the right of it. If there's no number written here, then it's not got a charge. That means that the electrons and the protons have to be even. So let's look at an example of an ion. So I'm going to use the same element, lithium. We'll say 3, and 7, but this time I'm going to put a charge right there. So what is an ion? It's nothing more than an atom that has a charge. So it's either gained or it's lost electrons. You said, well, how do you know if it didn't gain or lose protons? Protons tell you what atom it is. So if I wrote lithium down here with 3, it had to have 3 protons, which is lithium. So I'm going to go through, and protons is equal to 3. Neutrons, nothing changed, equal to 4. But now my electrons. If I know that a proton, according to our chart, has a positive charge, and I have 3 of those, and I know that the electron is negatively charged, how many electrons would I have to be neutral? 3 positives, 3 negatives, so that would make it neutral. If I wanted it to have a positive charge, that means I'd have to have one more proton than I do electrons. So now if I only have 2 electrons and 3 protons, that means that the 2 electrons would cancel out the charge of that, and I'd be left with 1 proton. So I come back up here, how many electrons would I have to have? 2, and that gives me a charge. So what is an ion? It is going to be an atom that has a different number of electrons and protons, therefore it carries a charge. That charge can be a positive or a negative. All right, the last one is an isotope. So I'm going to still deal with the same thing. The only difference on this one is we've talked about protons. What does protons do? Changes the element. It defines the element. We talked about electrons. What does electrons do? Changing electrons changes the charge of the element. Haven't talked about that neutrons. What do the neutrons do? The neutrons add or take away mass to it. So if I look right here, this one has a mass number of 8. So that means proton-wise, I have 3. Neutrons means I have 5, because 8 minus 3 is 5. That would give me the mass. And the electrons, since I did not put a charge right here, has to be equal to the protons. So do you see how the number of neutrons changed from what we had in our stable atom? I always get students say, well, Mr. Vance, how do you know what's considered stable atom? That is what you find on a periodic table. So I'm going to assign to you a periodic table so you can look at it and you can see the atomic number and its atomic mass. So in summation, what have we gone over? We've gone over the 3 different subatomic particles and how those 3 subatomic particles affect the atom itself. The protons define the atom. If you change the number of protons, you change the atom. The electrons give you its charge. If you have less electrons than you do protons, it's positively charged. If you have more electrons than you have protons, then it's going to be negatively charged. What do the neutrons do? The neutrons control the mass of it. So the neutrons makes what we call isotopes. So if it has a different mass than what you would expect from the periodic table, it is called a isotope. I hope you learned something from that and be able to go through and answer the worksheet that's attached.